Critical override. Listen up, team. I'm your fellow engineer on the Sex Saasos microkernel, and today's explainer is a classified deep dive into the absolute black hole of our hardware chaos. Our mission today? To establish the definitive architectural canon for our storage grid. Yeah, we are talking about SEXFILES, a revolutionary virtual file system, and exactly how it wrestles with the raw metal of our single address space operating system. Let's get right into it. Okay, quick look at the mission briefing menu. We'll hit the split brain authority hazard, move into the normalized I/O pipeline, break down the SEXFILES semantic state machine, look at PKU zero copy capability handover, and wrap up with our next deployment work. All right, section 1, the split brain authority hazard. So we really have to start with the threat that almost completely collapsed our Ring 3 isolation boundary. I'm talking about the architectural drift we suffered from overlapping responsibilities. You guys know that when your file system tries to act like a hardware driver, things just fall apart fast. Take a look at the strict decoupling we've engineered now. In the old model, we literally had Rust userland assumptions bleeding right into our hardware truth. It was a mess. But now, we are liquidating this split brain hazard by completely separating SexDrive, which handles the DMA hardware truth, and our NVMe or AHCI drivers, from SEXFILES, which is strictly our semantic file system. SexDrive is the absolute translation boundary now. And listen, this is a hard gate for our architecture. If SEXFILES parses an operation like OP file, right, directly, well, we implicitly rebuild a monolithic Linux kernel across our architecture. And there is absolutely no way we are doing that. It completely violates our core microkernel principles. SEXFILES shouldn't know anything about raw IPC commands.
Which brings us to section 2, the normalized I/O pipeline.
To actually tame this alien hardware and prevent that abstraction collapse, we had to implement a deterministic data stream. This acts as a strict translation matrix. The crucial point here is that SexDrive becomes the absolute only translator in this whole ecosystem. It generates this beautifully normalized form called the I/O intent. Because we have this canonical bridge object, the file system never has to know about IPC formats, user commands, or, random PCI bus signals. It just receives pure protocol-free intent. You can see our exact proven pipeline flowing down the grid right here. Linen, operating over in protection domain 2, sends the IPC request. Then SexDrive steps in as the I/O compiler and DMA scheduler, compiles that request, and normalizes it into our I/O intent. Finally, it routes that canonical form straight to the SEXFILES journal engine. It's a clean, deterministic, one-way flow of truth. And this gives us a massive system invariant. SEXFILES is mathematically blind to Intel and PK hardware keys and PCI bus signals. Literally, it only knows how to process truth objects, these I/O intents, to append data to extents. It is, by definition, a pure semantic state machine. Moving on to section 3, the SEXFILES semantic state machine. Let's move deeper into the vortex and dissect the engine itself. So, how do we actually represent storage in a single address space? Let's look at the abstractions that build our BTRFS and ext4-inspired architecture. It's kind of like a beautifully layered cake. At the very bottom, you've got block pages representing the raw hardware physical reality. Above them, extents group these block pages together logically. Then, inodes dictate the metadata authority, basically acting as the map for where everything lives. And finally, sitting at the top, file objects serve as the user-facing semantic abstraction. Now, we really had to face physical reality here. Real DMA hardware completions arrive completely fragmented out of the void. So we totally abandoned the legacy assumption of contiguous physical layout. Instead, our extents are natively scatter-gather, represented simply as a vector of block pages. But what about system crashes, right? To fix the whole inode mutation race condition, we enforce an append-only journal. We literally only update the in-memory inode when the hardware absolutely guarantees the transaction is physically sealed on disk. This gives us a crash-safe write-ahead log, meaning we never corrupt our metadata if someone pulls the power mid-write. And team, this is another hard gate. These are our exact, non-negotiable invariants. We have zero POSIX or Linux legacy assumptions, no standard libraries, no libc, no hidden threads. We strictly forbid raw cross-protection domain pointers, and we route exclusively through PDX. Doing all this ensures SEXFILES remains a perfectly deterministic state machine, utterly untainted by legacy desktop OS concepts. All right, section 4, PKU zero copy capability handover.
Here's the magic that actually makes our 360Hz single address space OS viable, treating memory as a zero-copy transport through this alien cyberspace. Because we all share the same virtual address space, we don't copy data, but we absolutely prevent abstraction collapse by utilizing capability memory tokens for all disk FOSS backend calls. There are no hallucinated, unsafe raw pointers allowed to compromise the Ring 3 boundary here. We strictly route via DMA call and DMA reply.
To securely grant access to that memory, we leverage the Intel MPK hardware lock. It's this beautiful 3-cycle atomic PKRU bit flip dance. First, we read the current state. Next, we grant the memory access via the WRPKRU hardware instruction. Then we perform the actual read or write operation and instantly restore the boundary lock. It is blisteringly fast, hardware-enforced security.
So think about it. Instead of copying multi-megabyte payloads from the kernel to the userland, SEXFILES just traverses the extent map and issues a true zero-copy handover read or handover write. It literally hands over a memory capability that's directly mapped to the underlying physical memory, granting that hardware key straight to linen.
Finally, Section 5, Next Deployment Work. We've mapped what's proven, so let's illuminate the frontier and see where we're taking the Sex Saasos storage grid next. Here is what is on the immediate horizon for us. First, we're targeting the tuxedo-wrapped NVMe driver right now for real hardware DMA validation. Next, we need to wire our lock-free LRU cache directly into the Sex demand pager, giving us that dynamic memory pressure scaling. And finally, we're going to expand our TempFS and DiskFS backends to push way beyond our current RAMFS bounds.
So, team, this brings us to the ultimate question for our next sprint. As we map out these final boundaries and touch raw silicon, are we ready to fully surrender those legacy monolithic safety nets? Are we prepared to completely trust the deterministic math of our capability engine to rule the hardware? Let's get back to the codebase and prove that we are.